Welcome back. You've now seen a couple of videos on hypothesis testing. This will be the final video in our series, and it's the most complicated. Here, we're going to talk about hypothesis testing with two samples. Let's say you've been hired by the Career Services Office of a local university's MBA program. They would like you to help them determine if there's any gender bias in the starting salaries of their graduates. So now we started to complicate things by adding this secondary variable. In the slide that you'll see on your screen now, I provided you with a sample of 10 recent graduates, their gender, their age, and their starting salary. Keep that in mind as we go further with the test. So our key variable of interest is salary, but we have a secondary categorical variable, gender, from which we're going to splice out, if you will, as a subset of the column for salary based on gender, giving us two subgroups, one for male and one for female, that we're going to test. All right? So first thing we do is set up our hypotheses. And now we want to be more specific. We want to know if the mean average salary for females is equal to males, and is this something we desire, or would the Career Services Office desire? Yes, because that means that there is no gender bias, at least based on the data that we have, or that the sample means or the population means for males and females are different. And if we have evidence that they're different, that might indicate salary bias in hiring of our recent graduates, and we'd want to know about it. Either way, we'd be interested in knowing. So from here, we can take a look at some of the sample data. For the females, we had 19 females. That was our sample size. Their mean average starting salary in the sample of 19 was $78,000. For the males, where there were a few more, 25, their average starting salary was $86,700. So there's an over $8,500 difference in those salaries. Looks like there might be some gender bias. Another thing that can help us understand if we have gender bias is the slide you're now looking at on the screen. I did a side-by-side box plot. And you can see it's a little hard to tell, but it kind of suggests that the males are earning more than the females. Well, that's what the statistical test is going to tell us not for certain, but give us a much stronger idea about. So we've got the sample size and the means. The next piece of information we need is that sample standard deviation. And that was 34,600 for the women, and 51,100 for the men. When we take that and divide it by the square root of the sample size for each one, that gives us our standard error for both subpopulations. 7.9 for the females and 10 for the males. So taking into account our measure of variation, standard error, the difference between these two sample means, are they statistically different enough to conclude that the population of all graduating MBA students has a difference in salary? Well, here, if you're not using computer software by now, you're not going to be able to get these numbers too easily. The formulas are quite complicated. So let's rely on the computer software to generate these numbers for us. And when they do that, we find that we get that p-value that we so desire to be 0.507. Is that less than our alpha? Well, let's see. So what alpha should we use? Any different than what we've done before? Probably not. Let's stay with 0.05. Our p-value was 0.507. Is that less than alpha? No, it is not. So what do? We do not reject the null hypothesis. And the check goes with HO. Here, that suggests that even though there was an $8,500 difference in the starting salaries, they weren't statistically different enough for us to conclude that the entire population of female and male starting salaries was different at our 0.05 level of significance. Which type of error could we have made? Type 1 or type 2? Only a type 2 here. But note that the p-value wasn't even close to 0.05, so it's probably not that likely that we would have made that error. Now, in a final thought with respect to this kind of two-sample testing, which again takes us to the next level of complexity in hypothesis testing and analytics, we dealt with a fairly small sample of only 19 women and 25 men, and the total was only 44. Sometimes you have to look carefully at that sample size and say, is that okay? Because when the sample sizes get too small, there are some key assumptions you need to make. Both of those sample sizes were well below 30, in which case we would have to assume that the underlying distribution of all salaries for men and women would have to be normally distributed. If they aren't, any conclusions we make would not be valid. So in this case, our summary here is, assuming that all the assumptions are correct and that our p-value of 0.5 is valid, there is no evidence of gender bias in starting salaries. That would probably be welcome relief for the Career Services Office and the Provost. Thank you very much for the series. Hopefully we'll see you again.